All right, so for today for Unit 8, Lesson 7, we're going to be continuing talking about similar triangles and kind of using some algebra to prove, or not prove, but find like side lengths. And there's a little proving that we want to do about like figuring out whether triangles are congruent or not, just like the last section. So for example 1, we are given the sides ED is 6, so let's start labeling right away. So ED is 6 over here. GH is 3, FH is 5, and FD, so this whole side over here, is, actually, we don't know what that is. We got to solve for that. So that's our X. Okay. So what we're going to do is, you can do this one of two ways. You can find the scale factor. You can set up a proportion to solve. There's multiple different ways to solve this, depending on what you want to do. What I like to do also is kind of separate the triangles. So I see that I have this little triangle over here, this GHF, and this bigger triangle over here, EDF. So what I'm going to do is I'm going to kind of separate them so I can see them a bit better. So I'll do the big triangle first. So we'll do D, E, and F. And that ED was 6. I don't know what FD was. That was my X. And then my smaller triangle was GHF, with GH being 3, FH being 5. So now I can kind of see what's lining up with each other. So like the 6 and the 3 are corresponding sides, the X and the 5 are corresponding sides. So I like to set it up as a proportion personally. So like what I do is I find my corresponding side, set it up like a fraction. So I'm going to do the 6 over 3. Equals, and then because I started with this triangle, I'm going to start with this triangle again and do X over 5. And then when we solve proportions, we're just going to cross multiply. 6 times 5 is 30, equals 3 times X is 3X. Divide by 3, divide by 3, and then 30 divided by 3 is 10. So 10 equals X. So that means my FD side, which is that X, was 10. For B, it says name two similar triangles and the postulate that can be used to justify their similarity. So we see that we have two triangles here. So one triangle is YAB. So let's separate those. We have a right triangle here, YA to B. And then we have the bigger triangle. Also has a right angle. That's XZY. Now, we see that we have two angles that are the same, the A and the X, because they're both right angles. So angle A is congruent to angle X. And we also see that they're sharing that angle Y. This has an angle Y and this has an angle Y, which means our Y's have to be the same since it's the same angle. So angle Y is congruent to angle Y, which means we can prove these two triangles are congruent using our angle-angle similarity postulate. So by angle-angle similarity, we can say triangle YAB is similar to triangle YXZ. So that would cover A. Now B, so this was our A. B, it says if A is the midpoint of XY. So A right here is the midpoint of XY. So that means these two sections are the same. AY is 12. Which means this would also be 12 down here. XZ is 32, so that's this section over here. Show algebraically that the two triangles are similar. So we kind of showed that over here with our angle-angle similarity. I would, let's see, we have 12, we have 12. Actually, I'm going to change this question a little bit, and we'll actually just solve for our AB over here, because I think that would be a good skill to do. So let's say our AB is, so solve AB. All right, so when we do that, what we can do is actually kind of use the triangles that we had here if we wanted to. So again, YAB. So my YA was 12. I don't have this side. And then over here, my bigger triangle, we have YXZ. So my whole side over here is 24 altogether. And then I got 32. So then what I can do is just set up my proportion again. So I could do 12 over, so 12 and 24 match up, equals my x over my 32. Cross multiply, we get 12 times 32, which is a pretty large number. So 12 times 32, that's going to be 384. Oops, 84. Let's go. 84 equals 24x on the other side. Divide by 24, divide by 24. We got x equals 384 divided by 24, 16. So at AB side is going to be 16. And then for C, given that triangle ABC is similar to triangle XBY, so they told us they're similar. If AX is 9, which is labeled for us, BY is 6, YC is 18, find the length of XB. All right, so for this one, we have to do a little bit more work. So we have two triangles here. So we have our smaller triangle, that's X, B, Y, and then this is like our question mark. So we'll say this is like our little X. This is our 6. And then our bigger triangle, doesn't look great, is CBA. Now, C to B, this whole side is going to be 24 altogether. 18 plus 6 is 24. And then this side, I don't know what this side is because I'm missing this part of it, but that's going to be 9 plus like whatever I'm missing, 9 plus x. So we'll put 9 plus x over here. Now, when we do this, let's see how we set this up. We can do 6 over 24 because those are going with each other equals our x over 9 plus x. Like that. And we're going to cross multiply. Now just be careful when you're cross multiplying. I am multiplying that whole 6 by everything over here. So I'm going to put in parentheses first. Times by 24x. Distribute that 6 out. So 6 times 9 is 54 plus 6x equals 24x. I'm going to minus my 6x over. We get 54 equals 24x minus 6x is 18x. Divide by 18, divide by 18. If you're not sure what that is, you can always use your calculator. 54 divided by 18 is going to be 3. So we get x equals 3. And then that x was our side length, so that's exactly what we're missing. So our XB side is 3.